In this video, we are going to discuss solve problem 9.3. The problem says the flywheel of a steam engine starts to rotate from rest with a constant angular acceleration of alpha equals 1.43 radian per second squared. The flywheel undergoes this constant acceleration for t equals 25.9 seconds and then continues to rotate at constant angular velocity omega. After the flywheel has been rotating for 59.5 seconds, what is the total angle through which it has rotated since it started? So here my flywheel starts from rest. And if it starts from rest, I can write my initial angular velocity omega I to be equal to 0 radian per second. After starting from rest, it is moving with a constant angular acceleration of alpha equals 1.43 radian per second squared, and it reaches a velocity of omega. So I will write omega final equals omega after t equals 25.9 seconds. So we can write this as t1, which is the time for which the flywheel is accelerating, to be equal to 25.9 seconds. This is the only time it has been accelerating for, and after this, it moves with a constant angular velocity of omega. We need to find what is the total angle through which it has rotated after the time of, let's say that time is t2, 59.5 seconds. We need to find what is delta theta for this time. Now my angular displacement, or the angle through which the flywheel rotated, can be divided into two parts. First part when the flywheel was accelerating, and the second part when it was moving with constant velocity. And after that, we can add the angle from both of these cases to find the total angle. When the flywheel was accelerating, we can calculate the angular displacement delta theta by using the equation of motion. So we write delta theta equals omega I t plus half alpha t squared. Now, since this is the region only when we are accelerating, we will take the time to be equal to t1 because it is only until t1 that the flywheel is accelerating. So let's write t as t1 here. Now substitute delta theta equals omega initial is 0 since we are starting at rest. So this whole term multiplied with 0 will become 0 plus half alpha is 1.43 times the time for which we are accelerating is 25.9 seconds squared. That gives me my delta theta to be equal to 479.63 radian. When the object is moving with constant velocity, I can find its displacement delta theta as omega times delta t, where omega is the constant velocity and delta t is the time interval for which it has been moving with constant velocity. Now the total time t2 of motion is 59.5 seconds. And for this, in this total time, t1 is the time for which the object was accelerating. So what is the time at which the object is moving with constant velocity? T1 is the time interval in which it was accelerating, and the rest of it is the time interval in which the object was moving with constant velocity. So I can find my delta t by taking a difference of t2 minus t1. What about omega? The question has not given me the final velocity omega. I need to first calculate what is omega, then I can substitute the value here to calculate the displacement. Omega we can find by using the first equation of motion, which says omega final equals omega initial plus alpha t. Here t is the time for which it is accelerating, so I will write t1. So omega final will be equal to 0 plus 1.43 times T1, which is 25.9. And when you multiply the two together, you get omega final as 37.03 radian per second. Now I will use this to find my delta theta. So we get delta theta to be equal to omega is 37.03. Delta t will be 59.5 minus 25.9. And when you solve this, I get delta theta as 1244.208 radian. Now these are the two values of my angular displacement, one for the time for which it was accelerating and two for the time during which it was moving with constant velocity. I can find the total angle theta by adding these two values. So we write the total angle delta theta to be equal to delta theta 1 plus delta theta 2. Then we add them. Delta theta 1 is 479.63. Delta theta 2 is 1244.2 radian. And when you add them both together, the answer you get is 1723.8 radian. And if you were to write this in three significant digits, as you have all the values over here, you get your delta theta as 1720 radian. So this is the total angle with which the flywheel has been rotated since it started.